So today we are talking about modern monitoring. And the purpose of this topic is sometimes you feel like the market is just trying to keep you on your toes with new terminology, new concepts. And we always like to say things are modern and new. But there's a reason for that. And at some point, you look at the new terminology and say, okay, this actually relates to a problem space that needs to be addressed. And that is true now in the world of application development, where monitoring has to change to keep up to speed with the velocity that is going on in the application development world. So, what is really driving this modernization? It's very practical, and actually, right now, during these times, has surfaced the reasons even more. So, the first thing is the cost of downtime is going up as we have more of our users, as tech-enabled enterprises have more of their users interacting with them via applications. That means the cost of downtime for those applications is much higher. So there's a big cost here. But it's not just the cost of downtime. There is an opportunity cost of not collecting data from these platforms and leveraging that data to do even better. And the big part of that opportunity cost is you can get leapfrogged, and you will get leapfrogged very quickly if you are competing in a legacy market where new players that are built cloud native are participating. The other thing that's driving this is that organizations are finding that their approach to infrastructure and servers, they can't think about racking and stacking servers anymore. It's just not going to work. To keep up with application velocity, they have to change the infrastructure that supports it. And right now, more than ever, we've seen that organizations who were not embracing DevOps practices were in trouble when the pandemic hit because they needed to adapt their applications very rapidly in months time frame, week time frame, to better support their users with specific pandemic related functionality in their applications. You can only do that if you're in a DevOps methodology. So organizations are thinking, how do we prepare for the next crisis, whether it's more related to the market or whether it's global? How are we making sure that we are set up that we can address the technical challenges related with these crises? And finally, and this is one that all organizations have to consider. As companies become more tech enabled, if they want to hire top technical talent, they need to be looking at modern development practices and modern infrastructure. So these are all components that are really driving organizations to think about going from just maintaining the infrastructure and the monolithic applications they have and moving into the cloud and more into the cloud native application direction. Most organizations are going to find themselves in the lift and shift and refactor phases. And some could argue that you have to lift and shift before you refactor. I don't think that that's actually true, but it is an important step when organizations start to think about moving to the cloud. The problem with lift and shift is they're just cloudifying old practices. Refactor is when they start to really isolate components of their existing environments and applications and modernize them more in the direction of cloud native. Cloud native is often what we think about as the unicorns. Cloud native is somewhat what you think about those companies who have applications born in the cloud and already leveraging the power of public cloud services across not just infrastructure, serverless, multi-cloud, hybrid cloud, etc. And it's not just the infrastructure portion of this. It's very important to know, and Dave is going to tell us now how the applications themselves are changing dramatically.
Thanks. So, as Chris has laid out here, what we're seeing as part of this is this move, of course, across this cloud native journey. But the biggest change that's happening is kind of the development environment that's driving this. And what we've seen is a distinct shift from this monolithic, everything all together architecture into a more services oriented architecture. You usually hear the phrase microservices. used inside of here. There are some really distinct differences that come across here. For instance, monolithic architectures tended to be written in a single language. They may have a couple of parts, and they updated themselves very infrequently. At a former company, for instance, the monolithic suite only updated every 18 months, even though the teams would come out with new features that our customers would clamor for just about every 2 weeks inside of here. But because we were on this monolithic, everything had to work perfectly the first time through. We ended up with this very slow moving product set. This also meant that we had less transactions. We had sawtooths that happened inside of here. And a suite release was nightmarish for the operations teams, the developer teams, everybody, because it impacted so much at the same time. As we move to the microservices architecture, we start making use of services that are loosely coupled. They're using communication aspects to drive across each of these pieces. And those services can be any language they choose to be. It can also be third-party pieces. So they don't have to write every single thing and integrate it together. They're now making use of communications. Think of microservices as a small application that does a job very, very well. Doesn't notice that it's not as small as possible, but as small as necessary becomes inside of that. And so you now have lots of different pieces that can be running in lots of different places. They can cross cloud boundaries inside of here. And because they tended to do this functionality on a very individual basis, they can be pushed as each service updates inside of this. Next slide, please. So one of the things you'll see is that we now have a very complex environment. And the tracking that we go through to find out how our requests go through our systems is now no longer as easy as saying, oh, it's running on server foo over there. It's now where is it running and when is it running? So this is an example of a service map, and it's actually an e-commerce based service map. It's a fairly simple one, and it's showing the progression of requests as they flow through the system. Behind each of these service maps, we could break down and show more information around this. Everybody's probably familiar with the Amazon e-commerce site. The Amazon e-commerce site alone, the page that shows you an item for sale, is made up of 18 microservices. Behind every one of those microservices is somewhere between 3 and 5 additional microservices. And behind those microservices, quite often there are 1 or 2 more that happen. So now all of a sudden what you're looking at, what was a very simple, here I want to buy something, it still is from the user viewpoint, but from the back end viewpoint, for the guys that are keeping this running, is suddenly incredibly deep and incredibly complex. But it's also worth noting that when the current time started, Amazon was having trouble keeping up with shipping. And so one of the things they did to alleviate some of the shipping pressure was they turned off the microservice that said, oh, this is usually bought with. Something as simple as that meant they didn't have to rewrite the application. They just turned off one single service, and it impacted the way they did business. That's the impact that you can have when you see a microservices-based architecture. And so you're going to hear a couple of interesting terms inside of here. This is one of my favorite quotes around this. So monitoring lets you ask why things are there. Or what's going on with the system here. Observability is the data that lets you ask those questions. And we talk about observability as being able to talk about unknown unknowns. But in the past, back in that monolithic days, we had what was called black box monitoring. We'd sit on the outside world and we'd have these things like Nagios, which simply constantly ask the server, are you running? Ask the application, are you running? Consider it like looking at your television set and seeing if the power light is on. That's the equivalent of a black box monitor. You know that it's getting power, but you have no idea what's going on inside of that. If you suddenly have a loss of signal, you have no clue as to where the signal get lost. Did it get lost at the satellite? Did it get lost inside your television? Is there sunspots causing? You don't know. But now we have this concept called white box. And white box actually looks inside of the application. And it starts taking the data and say, what are you doing? Are you being successful? How long is it taking you to do those things here? So monitoring tells us whether the system works. And when we move into this more complex microservices, service-based, native cloud models, we need white box monitoring because we now need to know what each piece is doing. We'll give you monitoring. Well, no, we mean observability. One of the myths you're going to occasionally hear still surface is that monitoring isn't observability. That's true. Observability is the data, but the data by itself is not useful. So monitoring enables us to observe our applications. The nature of monitoring has to change for this. We now have more data, we have more sources, we have more aggregations, and we have more places to go find the data. And at the same point in time, we are also getting the massive hit of a instant gratification society. Microsoft's study points out that the average um, attention span for an adult is about 8 seconds. Google's study shows that if you wait 3.7 seconds for a web page, you're likely to leave the site. So monitoring has to change. So I'm going to cover sort of the things. The first one inside of here is that we need to be seeing things in real time. We can't wait for things to happen and then find out about them 5 minutes later or even a minute later. Right now, for instance, you'll hear a concept called serverless. In AWS terms, lambdas. Here, lambda startup time in a warm startup is 30 milliseconds. So imagine how many Lambda startups you could miss if you didn't see the information until every 5 minutes. You see so many things that could possibly go wrong at that point in time that you would be hopelessly lost behind the curve, and you probably would not pay any attention. So you need real time. You need streaming functionality. Chris, you want to cover push and pull?
Thanks, Dave. Another key aspect of this is that in the traditional monitoring perspective, you had a pull approach. So you kind of waited until things broke, and then you knew where you were going to go to figure out what broke. It's usually you start with the log and you go there, there's the information. That's great, but some of the problems of it, it's often too late. And in that case, in that environment, it is easy to know where to go because, as Dave said, back in the day, you would name your servers. They were so static, you would give them names. But you can't do that in modern infrastructure because things spin up, spin down on an hourly and in the serverless space, microsecond based. So you need a system that can tell you what's going on and tell you where it is because the dependencies are too much for an individual to know where to go to find the information. So it has to push. And that is another big key element in the observability paradigm. The other thing that is parallel to this is the SRE model. So the knock is changing in the operations world that is supporting applications, public applications. The knock is changing. You can't have a staffed knock and do a spray and pray approach when things break. It's either spray and pray where you just blast everybody and hope somebody picks it up, or you call that one person who fixes everything. It doesn't work. In modern applications, the stacks are too varied. Every service has its own life cycle, and you're just going to burn out the entire team if you're always just calling one person or you just expect everybody to kind of come in and firefight. So in the SRE model, things change because most everybody is now on call. Developers, if you build it, you support it. You are on call for your code. You need to be because you're the one who understands your service the best. So the knock is transformed more into a strategy, and that strategy includes observabilities. SREs tend to be the stewards of on call and stewards of observability, um, like they do with us. Again, I did it. But they are not always the ones that are on call. They usually are on call for some components of the application, but not the entire application. So these models go hand in hand, and they are all driven by the application. The application is telling us they're more complex, they're moving faster, they need a new type of management plane. All right. So we've already basically said this, but observability is driven by a new development strategy and a new deployment strategy. We're not just trying to throw new terms at you to confuse you because it's fun. This is a thing that is tied to what I said before, a real problem space. The approach to monitoring applications has changed because of this, and there now is a set of tooling, which is the observability platforms, to make that complexity easier. So, when do you consider observability? Because let's be honest, not all enterprises are just going to have observability approaches across their entire stack. They're still going to have monolithic applications, etc. One of the things that we haven't said yet, but it hopefully was obvious, is that the lines between infrastructure, where the applications run, configurations, the configuration of that infrastructure, and the code itself have blurred. They are becoming one and the same. You are shipping infrastructure. So that alone means that you need a new approach. So that is a key part of it. When you find out that the compute metrics, the standard compute metrics, are not going to be enough to support your application, some services have a slew of metrics that they're managed by that are unique to them and even unique to the application and the organization. When applications are increasingly distributed, hybrid cloud, multi-cloud, all of these things, multiple regions. One version of application version can be deployed across multiple regions and multiple clouds all at the same time. And the components of the application are stateless and ephemeral. They live and die very quickly. You don't deploy code onto a server anymore. You rip down the server and replace it very rapidly. So these are the times when you have to consider an observability platform. And in a lot of cases, the organizations that aren't doing this proactively are being forced into it because their development team and the nature of these applications are demanding it.